Hi everyone, Aaron here from YetiTool, and in this video we're going to be explaining how to use the advanced profiles features when using YetiPilot. YetiPilot comes with a range of preset profiles for different materials and cutters, and we'll continue to grow this range with free software updates. However, you may want to work with a material and cutter combination that we don't yet have a profile for. We're going to show you how you can still use YetiPilot with the Advanced Profile tab to create your own bespoke profile. First, we'll explain how to prepare your job files, and then what you need to do on your SmartBench console to create an advanced profile. If you haven't already, we recommend you watch our other video on how to use YetiPilot with a preset profile first, and then come back and watch this one. The first step is to prepare your job file, and in this video we'll be using Vectric VCarve Pro. The critical strategy parameters for YetiPilot to perform are feed rate, spindle speed, and step down. If you are at all unsure on what these terms mean, then please check out a guide to understanding cutter strategy which covers these terms and more. If you're unsure on where to start with the feed rate for your material and cutter combination, then you can actually use YetiPilot to find out. Simply input a feed rate of 4,000 millimeters per minute. This is because YetiPilot can adjust the feed rate up to a maximum of 200%, allowing SmartBench to reach its top feed of 8,000 millimeters per minute. Be aware that this value is the feed rate which the cutter first enters the material to allow YetiPilot to respond. So if you're using a delicate cutter or your material is particularly hard, you may want to start with a reduced feed rate. If you're not sure what your spindle speed should be, then we would recommend around 22,000 RPM as a good starting point. From there, you'll be able to easily adjust your spindle speed mid-job using the SmartBench console. A few things to look out for. If your spindle speed is too low, then you might see excessive vibration in the machine. If it's too high, then you run the risk of burning your material. We typically recommend keeping the feed rate high by using shallower step downs, if the cutter allows. This helps prevent heat build-up, which could potentially burn the material and damage the cutter. If you want some inspiration on setting your step down values, then please see our strategy tables. Before we move on to the console, it's important to understand how YetiPilot works. The goal of YetiPilot is to maintain a constant spindle load throughout the entire job, and YetiPilot will change the feed rate to achieve that. So if the load is too high, YetiPilot will reduce the feed rate to compensate. And if there's too little load in the spindle, YetiPilot will increase the feed rate. So your challenge is to pick an optimal target spindle load. One that's high enough to produce a sensible feed rate, but not so high as to cause excessive cutter deflection or damage. Before starting your job, we recommend doing some test cuts in some spare pieces of stock to check that there aren't any problems with your cutting parameters prior to starting your job. This is worth doing because it will help you determine whether the target load you've chosen is suitable for what you're trying to achieve. You can adjust this if needed during the test cut until you're happy. For example, let's say you're using a small 3mm cutter like this one for some detailed work. These cutters are not particularly strong, so if you set your motor load too high, you're likely to see some cutter deflection, which can lead to inaccuracies in your cut. To increase accuracy, you want to set a lower target spindle load. This is to ensure that YetiPilot isn't going to adapt your feed rate too high and cause excessive cutter deflection. If you're looking to optimise your cutting time with a stronger cutter or on a softer material such as poplar plywood, then you can experiment with increasing your target load. If you're concerned about accuracy, then we'd always recommend adding a finishing pass to your strategy, which will clear up any inaccuracies in your cut caused by tool deflection. For more information on how to add a finishing pass in your CAM software, please see our dedicated knowledge base article. If you want further advice about cutting different materials on SmartBench, then join the growing community of SmartBench users in the YetiTool Talk group on Facebook. Here, thousands of SmartBench users post every day, sharing their projects and knowledge with each other. So if you're looking for advice on parameters to use as a starting point for a material that isn't in our database, be sure to check it out. Now we're ready to load up our job on the console and turn on YetiPilot. When you switch YetiPilot on, this will open up the Settings tab where you'll find preset profiles. Navigate to the Advanced Profiles tab. The first thing it will ask you to do is run a spindle motor health check. This will take a few seconds. Once that's finished, it will display a target motor spindle load, which will be the free load required for the motor to spin in the air. Set your target load to around 100 watts above the minimum, and then gradually increase this over the course of your cut until you've reached your optimum feed rate. For guidance on knowing when you're operating at a good feed rate, please see our article on assessing cut strategies. You're then ready to cut with the advanced profile. Be aware, it's not currently possible to save these custom profiles. If you're wanting to repeat your job, then just make a note of your target load settings for next time. We hope you found this video helpful. Good luck and have fun using YetiPilot with a diverse range of materials that you can process on SmartBench. Thanks for watching, see you in the next one.